Welcome to section 20.1, part 2. This is the 199th session of the CISSP exam prep series. This part shifts from language choices to the practical safeguards that keep running software from failing dangerously. In this session, we'll examine how to keep applications resilient and how to structure their development. We'll answer several questions. How do you stop bad input from breaking a program? How should applications handle authentication and sessions? What do error messages and logs reveal, and to whom? When software fails, should it lock down or open up? And how does a formal life cycle guide the earliest phases of a build? Why does this matter beyond the exam? Because the difference between a minor glitch and a full breach often comes down to these unglamorous choices. Imagine a hospital's appointment portal that a patient can reach from any browser. If it trusts whatever text arrives or spills its database layout in an error page, an attacker gets a roadmap. Getting input handling, failure behavior, and phase discipline right is what keeps that portal boring instead of newsworthy. How do you stop bad input from breaking a program? You validate it. Input validation checks that whatever a user submits matches what the code expects before anything acts on it. If a field asks for a month, the program should insist on a whole number from 1 to 12, a rule called a limit check, and politely reject anything else. It also scans for suspicious characters that hint at an attack, and it can neutralize risky sequences by escaping them, swapping dangerous symbols for harmless stand-ins that display the same but never execute. The one rule you never break is to validate on the server, because anything running in the user's browser can be tampered with and slipped past. Think of a bouncer who checks every guest at the door, not one who trusts the guest list they were handed. How should applications handle authentication and sessions? Match the strength of the login to the sensitivity of what lies behind it. An application holding sensitive data or letting users run critical operations deserves strong multi-factor authentication, not just a password. Wherever possible, plug into the organization's existing hardened identity system rather than inventing your own. And if you truly must build one, lean on externally vetted authentication libraries. Sessions need the same care. Any cookie that tracks a session should travel only over encrypted channels, carry a long random identifier, and expire after a set time so users must sign in again. Picture a wristband at an event that is hard to forge, tied to one person, and stops working once the show ends. What do error messages reveal? And to whom? Developers love verbose errors because they make debugging painless. But those same messages can hand an attacker the internal map. A detailed error can leak database table names, internal server addresses, and other reconnaissance gold. So on anything publicly reachable, switch off detailed error output, often called debugging mode, and show users only a bland, safe message. The valuable details should not vanish though. It belongs in logs. What should you log, and why does it matter? The rich information that would endanger a user-facing error page is exactly what your security team needs behind the scenes. Send detailed records of errors and security events to a central log repository where analysts can study them. Capture the events that tell a story of trouble, like failed input validation, authentication attempts and especially failures, access control denials, tampering with saved state, use of expired session tokens, system exceptions, administrative and security setting changes, and cryptographic or secure channel failures. Together, these give you the trail to diagnose issues and investigate incidents. Think of a store's security cameras. You do not broadcast the feed on the storefront, but you keep it recorded for when something goes wrong. When software fails, should it lock down or open up? You must decide this in advance, because failures are unpredictable and code will get used in ways nobody imagined. A fail-secure state throws the system into a high-security posture or shuts it down entirely, until an administrator can investigate and restore it. A fail-open state does the opposite, letting users slip past the broken control and erring toward permissiveness. In almost every environment, fail-secure is the right default because it blocks unauthorized access when things go wrong. The blue crash screen on a desktop operating system is a familiar example. When the system detects that its environment is no longer trustworthy, it halts rather than keep running in an unreliable, insecure state. What happens after a fail-secure event, and when is fail-open ever acceptable? Once a system safely stops, you choose whether it stays halted for a human to review or reboots itself automatically. Staying down forces an administrator to step in, which you can enforce with a boot password. Automatic recovery needs no human, but it must reboot into a restricted state, never auto-logging in and always prompting for credentials. Failopen is a rare exception, sometimes justified for a lower layer of a multi-layered defense, and only after you clearly validate the business need and back it with alternative controls. Remember too that ship security is often switched off for easy installation, so administrators must deliberately turn it on. Every notch of added security tends to cost more, add overhead, and trim convenience, so you are always balancing protection against usability. How does a formal lifecycle guide a build? Security works best when it is planned and managed across the system's entire life, and project management keeps that effort on track. Formal lifecycle models embed good practice and security into every stage, instead of leaving it to chance. Whatever the model, the same core activities recur. You define the concept, determine functional requirements, develop control specifications, review the design, write the code, walk through code reviews, run system testing, and then maintain and manage change. Do not obsess over the exact labels, which shift from one text to another. Grasp how the flow works. Think of it as a recipe with named steps. Different cookbooks phrase them differently, but the sequence of preparation stays the same. What happens in the conceptual definition phase? You write a short concept statement, agreed by every stakeholder, developers, customers, and management alike, that captures the project's purpose and its broad requirements. Keep it to a paragraph or two, high enough that an outsider grasps the whole aim in a glance, like the abstract at the top of a report. The security requirements here stay very high level and get refined later, but this is where you flag what classes of data the system will handle and their handling rules. Reread the concept statement throughout the project, because the daily detail has a way of hiding the overarching goal. What happens during functional requirements determination? Once everyone agrees on the concept, the team spells out exactly what the system must do and how its parts should work together. The deliverable is a functional requirements document written in a form developers can build from. Each requirement rests on three characteristics: the inputs, meaning the data a function receives; the behavior, meaning the business logic that decides how the system reacts to those inputs; and the outputs, meaning the data the function hands back. Get every stakeholder to sign off before moving on, then keep the document alive as a constant reference and, at the end, as the checklist that confirms every requirement was met. Think of it as the blueprint the whole build measures itself against. Why give control specifications their own phase? Because security designed in from the start integrates cleanly, while security bolted on later leaves gaps. This phase, sitting just after functional requirements and running into design, is where you analyze the system through a security lens. You build in access controls, so only authorized users get in and none exceed their permissions. You protect confidential data with appropriate encryption. You provide an audit trail for individual accountability and a way to detect illegitimate activity. And for critical systems, you address availability and fault tolerance. Revisit these requirements every time the design changes significantly, because a major component shift usually shifts the security needs with it. Retrofitting security is like adding a fire escape to a finished tower. It never fits as well as one planned into the frame. What happens at design review? With functional and control specifications settled, the designers work out exactly how the pieces interoperate and how the modular structure lays out, while management assigns tasks and sets coding timelines. When the formal design documents are done, the stakeholders meet to confirm everyone still agrees the project is on track to deliver the intended functionality. Crucially, security professionals belong in that room, validating that the proposed design honors the control specifications set earlier. Think of it as a dress rehearsal review before the cameras roll, catching mismatches while they are still cheap to fix. So let's bring it together. Validate every input on the server and match authentication and session handling to the sensitivity of what you protect. Hide detailed errors from users, but log them centrally for your analysts. Default to fail secure so trouble locks things down, and treat fail open as a rare, justified exception. Then structure the build with a formal life cycle, moving through concept, functional requirements, control specifications, and design review, weaving security in at each step. Master these habits, and resilient software becomes the default rather than the exception. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.